finally agrees to design and develop the new Virginia class. But to bring it in more cheaply than the Seawolf, they'll have to completely change the way submarines are built. It starts with paper and wood. In the past, they would have drawn up initial plans on paper.
Previous classes of submarines were designed historically like probably any other large construction project with two-dimensional drawings, blueprints.
But the problem with two-dimensional plans is that the different designers can't always view each other's layouts. If two engineers from different departments end up competing for the same space, it could lead to lengthy and costly delays. On this tight schedule and budget, there's no room for such error. It'll put the project behind schedule even before it started. It could tip the balance and mean the end of the new super sub. The team needs another solution. They turn to new computer-aided technology. The benefit being that the whole model can be seen in 3 dimensions. This will mean that each department can quickly see what the other is doing. If it works, it'll save the company a fortune and help design a more efficient sub. But if it doesn't work, it could mean the new super sub is doomed from the start. The president of Electric Boat finally decides to take the risk.
He came in and finally took all the drafting boards out of the plant and said, okay, go for it on your computers.
Before the Virginia class, when a submarine was designed on paper, builders would then construct a life-sized wood mock-up of the plans just to make sure everything fit. But with the computer-aided design of the Virginia, that step could be skipped. All of the test fitting could be done right there on the screen. It is the first time that a US Navy submarine is completely designed via computer. And the program that would make this computer-aided design possible is already proven technology. Known as the CATIA program, it has effectively been used in the development of airplanes by the Boeing Corporation. Electric Boat figures there are enough similarities between a plane's fuselage and a submarine to take the plunge. It proves to be the right decision. All the various designers have access to the computer 3D model. This allows engineers to work in the same virtual space at the same time. Designers can now view all the plans to make sure they don't interfere with other layouts.
The piping designer is running his pipes and I'm running my cables. We can go in and detect interferences day by day.
Every part of the ship is scrutinized for function and economy. So creating the sub on a computer seems to allow for the more efficient test fitting of systems and parts. But the next challenge facing designers is figuring out how to create spaces for people. Workers need room to do installations, and sailors need space to do their jobs. So in order to ensure those spaces are adequate, designers welcome the help of this guy. Meet ErgoMan. ErgoMan is a computer-generated image of a human being that comes in 3 virtual sizes: 1.7 meters, 1.8 meters, and 1.9 meters. Whatever movements a human can do, ErgoMan can replicate. Then, when the ergonomically correct envelope has been pushed and movement is made that is not humanly possible, ErgoMan clearly lets engineers know by simply turning that body part red, enabling the designer to adjust the space he's working on. This revolutionary technology could save the company millions in costly redesign. It could also guarantee that the crew will operate at maximum efficiency. The computer-aided design also helps in one other crucial way. The future of warfare is uncertain. To meet that uncertainty, this incredible sub must be able to adapt to new situations. As modern warfare changes, so the Virginia must adapt to meet it head-on. To create this adaptability, the designers of this super sub create what's called a modular design that incorporates an open system architecture, meaning the skeletal structure of the sub includes large open spaces. These open spaces can house prefabricated modules such as weapon systems or sonar technologies. These modules can easily be inserted as one complete unit. This modularity will allow future versions of the Virginia-class to house newly developed systems in the existing Virginia-class layout, without the added expense of having to develop an entirely new class of submarine to house new technologies and capabilities. A remarkable cost-cutting development in the design of a submarine. If it works, this will be the most extraordinary submarine commanding the world's oceans. But designing it is just one problem. Making this ambition a reality is quite another. With an even tighter budget than past submarines, this is going to be a massive challenge to execute. And now there's a new problem. Having spent millions on the design, the Navy may not have enough money left to build it. It looks like the prototype of the new Virginia-class may never surface. The Navy is underwriting an enormous new project to build a new class of submarine that'll be more versatile than any ever built. But it has to be constructed in less time and for less money than the previous attack submarine, the Seawolf. The design and development have been skillfully and successfully carried out by Electric Boat. And for the first time, a US Navy submarine is completely designed via computer. It's a massive achievement, but there's a problem. The Navy's budget for the Virginia program is running out. It could lead to the end of the new super sub before it's even floated. But then Electric Boat does something unprecedented in its history. For years, Electric Boat has been in competition with Northrop Grumman's Newport News, another heavy hitter in the shipbuilding industry. Now Electric Boat proposes that they combine forces with their old rivals and do something that's never been done before: build the submarine together, a process they called teaming. They figure that combining resources and brainpower will allow them to work more quickly and more efficiently. The proposed alliance can lead to massive savings, $700 million off the cost. But can these two historic adversaries put aside their differences and build a super sub for a reduced price? How can they manage such a massive project across two companies? As we've said, it's never been done before. But the Allied companies must make it work. They have little choice, as the Navy has no more money to offer. Making a super sub for less money and in less time than previous attack subs will only be possible if the two rivals collaborate. It's a colossal and dangerous undertaking. If they get it wrong, it could spell the end of the US submarine program. This is a time when the Navy must prove a submarine's worth in a changing world. The two-company alliance agrees that the only way to meet such demands is that there can be no delays. A major setback could erase any cost savings. But such efficiency in submarine construction is unprecedented. Is this project simply too ambitious? Could it be destined for the deep? In 1998, construction finally begins. Like all submarine building, it begins with the most crucial component, the hull. This is where the crew and weapons are housed. If it's not strong enough, the lives of hundreds of men are at stake, as is the multi-billion-dollar submarine. Not just a costly mistake, it would be a national catastrophe. Consequently, the hull for this sub isn't just made out of simple steel. It must resist unbelievable pressure. The Virginia-class needs to reach depths up to 240 meters. Here, it's difficult for an enemy to find them, It'll give the submarine maximum safety from attack or detection. But at these depths, there's immense pressure. The steel hull must withstand a massive 26 kilograms of force per square centimeter. That's the equivalent of a dinner plate strong enough to hold up to the weight of an elephant. Getting the steel strong enough to endure such pressure is crucial. The manufacturing of this special metal is a military secret,